The Lanzatech process takes the waste gases from many industries, including the steel manufacturing industry, the chemical industry, and refineries, and recaptures the carbon to ultimately produce ethanol and other useful chemicals. The industrial waste gas undergoes steam reformation, producing carbon monoxide and hydrogen gas. These products are then fed into the Lanzatech reactor. The Lanzatech reactor is a continuous stirred tank or bubble column reactor and contains proprietary microbes in a nutritious broth. The carbon monoxide containing gas, which is fed into the reactor, is fermented by these proprietary microbes. In the presence of hydrogen gas, these anaerobic microbes have the ability to feed off of these toxic gases and produce alcohols, acids, and other useful industrial chemicals. The products of the Lanzatech reactor are then transferred into a separation system. A recycling stream connects the separator to the Lanzatech reactor, and water is passed back into the reactor. The desired products are then filtered into separate containers and are then ready to be delivered to customers.
Hello, Camila and I are studying the company Lanzatech, which is a biofuel company that develops sustainable paths to fuels and chemicals by using proprietary microbes. The company's microbes convert waste gases to fuels and chemicals from various syngas sources. Remember that syngas is carbon monoxide and hydrogen gas. These microbes are typically some form of carboxytrophic microorganisms such as Clostridium, Morella, and Carboxydithermis. Lanzatech's biological microbes can utilize the lowest cost, most readily available gas resources. This is a key aspect of their business model. Such sources include industrial waste flue gases from steel mills, processing plants and refineries, syngases generated from many biomass resources including biogas, biowastes, organic industrial wastes, and agricultural wastes, coal-derived syngas, and reformed natural gas. It is the only process that converts waste gases to fuels and chemicals from any source of carbon monoxide. This means that Lanzatech's approach offers great potential to curb greenhouse gas emissions while at the same time adding value-added product to the market. It's important to note that while microbial fermentation of carbon monoxide in the presence of hydrogen can lead to substantially complete carbon transfer into an alcohol, in the absence of sufficient H2, only some of the carbon monoxide is converted into alcohol, and a large majority is lost in an inefficient conversion to carbon dioxide. Thus, in order to get maximum yield, the company Lanzatech oftentimes uses processes to form syngas, including steam reforming of natural gas or biogases to greatly increase their yield. Waste gases had never been used before as a nutrient source for the conditioning process. As a nutrient source because the conditioning process made it economically unfeasible. However, Lanzatech's microbe does not require the microbes to be conditioned, and thus can use any low-cost waste carbon monoxide containing products as a nutrient for growth. This leads me to the fact that Lanzatech's in-house synthetic biology capability is singular. That their microbes are developed in-house bestows the company with a unique advantage to efficiently engineer new proprietary microbes. Lanzatech's expansion of its line of microbes seeks to pave the way for the company's entry into higher value chemical markets going forward.